as a function of x, okay, is the equation of the distributed load. So this, in fact, is equal to omega naught over L x, right? So because the gradient is omega naught over the distant length, right? So it's positive gradient omega naught over Lx. So when that's the case, we know that this has to be negative. You put minus omega naught over Lx. Okay. And then from here, we have to integrate v as a function of x. We have to integrate minus omega naught over Lx dx. So this will be equal to minus omega naught x squared over 2L, right? And then we have plus by C1. Okay. Then we come back here, right? So this is x is equal to 0, x is equal to L, V m theta y, V m theta y. The only thing we know that this is 0, and then this is 0. The rest, we know nothing. Okay. So exactly that what they have over here, you see all the boundary condition. It's exactly that what we have just done. Okay, so we know the boundary condition is correct. So from here, right? From here, the next thing we do, and we know, right? This will be equal to dm over dx. Okay. So now, what happened now is when we found that m at point A, this is equal to x is equal to 0. Okay. So x is equal to 0. We found a moment acting on the beam. Okay. So in this case, what we are going to do now is we are going to do m as a function of x and m at point A, and then this will be equal to integrate between 0 to x minus omega naught x squared over 2L plus by C1. Okay. So immediately we know that m as a function of x, m at point A, this is also equal to m at 0, right? So we have over here minus omega naught L squared over 3 plus by BYL, close the bracket. And then we integrate, we have minus omega naught. So integrate, I do apologize, I need to put dx out here. So omega naught x cubed over 6L plus by C1x. Okay. And then the limits is 0 to x. Okay. So from here, we have formulated m as a function of x will be equal to minus omega naught x cubed over 6L plus by C1x, okay, minus by omega naught L squared over 3, okay, plus by BYL. Okay. So then we are going to apply elastic curve. So EI d squared y over dx squared. So at this stage, this is where we apply the elastic curve. Okay. So from here, we can write down, we integrate the EI theta or EI dy by dx. So this will be equal to EI theta. So this will be equal to minus omega naught x4 over 24L plus by C1 x squared over 2 minus by omega naught L squared over 3 x. And then we plus by BYLX. And then we plus by C2. Okay. Then we are going to use our boundary condition. Okay, we're going to use this boundary condition over here, where x is equal to 0, the slope will also be equal to 0. So from here, we're going to substitute x is equal to 0, theta is equal to 0. And we know, okay, x, so C2 is equal to 0. Okay, so therefore, dy by dx will be equal to minus omega naught x4 over 24L plus by C1 x squared over 2 minus by omega naught L squared x over 3 plus by by Lx. Okay. Now if you look like, oh man, one equation, two unknown. We have a C1, we have by. Look, a lot of times when you have problem like this, okay, don't just stay there and do nothing. I repeat again, don't just stay there and do nothing. Okay. And what I mean by that, keep on beating on it. Okay, keep on going. Okay, keep on going. Okay, if you stay down there and not doing anything, then that's where problem will come. Okay, keep on going. Okay, so you integrate again. So we have minus omega naught x5 over 120L plus by C1 x cubed over 6. Okay, minus by omega naught L squared x squared over 6. Okay, plus by by Lx squared over 2 and plus by C3. Okay. Then we are going to use our next boundary condition, which is this one over here. Okay. So when we use that boundary condition, we have when x is equal to 0, y is equal to 0. Therefore, we also realize that C3 is equal to 0. Okay. So from here, okay, from here, it still looks like, oh, miserable, still very long. Okay. Move, okay. Don't stop. Okay. Don't anticipate, because at this stage where you are trained, you don't have the experience to anticipate yet. Okay. So keep on doing it. Okay. So now we know that I'm going to copy this whole thing. Right. And then I'm going to paste over here. We know that C3 is equal to 0. That's why I did not include C3. We have another boundary condition where x is equal to L, y is equal to what? 0. Right? So it's this boundary condition that we're going to use now. Okay, where x is equal to 0. Sorry, x equal to L, y equal to 0. So this side will be equal to 0. And this will be minus omega naught L4 over 120 plus by C1 L cubed over 6 minus by omega naught L4 over 6 plus by by L cubed over 2. Okay. So when you have to remember, when you put in the boundary condition, we are trying to solve for what? C1. Okay. And we are not trying to solve for by yet. We are trying to find what is C1. Okay. So from here, we need to rearrange a bit. Okay. So we have minus 101.20 minus 1 over 6 minus 1 minus 1 over 120 minus 1 over 6. You get minus 70. So this is 0 minus 70 over 40 omega naught L4. So these two are done. Okay. And then we have plus by C1 L cube over 6 plus by BY L cube over 2. So we write down C1 L cube over 6 will be equal to 7 over 40 omega naught L4, right? And then minus BY L cube over 2. So from here, we know that C1 will be equal to 6 times 7 over 40 will be equal to 21 over 20 omega naught L, okay, and then minus by 3 BY, okay, minus by 3 BY. So from here, we can, so what we are trying to find is determine BY. Okay, so we have to determine what is our BY, and BY is at X is equal to what? X is equal to L. Okay, so now we are going to use the shear force equation. Okay, so the shear force equation is equal to what? V as a function of X is equal to minus omega naught X squared over 2L plus by C1. So we have a C1 value. So this in fact is equal to what? Is equal to minus omega naught X squared over 2L plus by C1 is 21 over 20 omega naught L minus by 3 BY. Okay, minus by 3 BY. Okay. So now, if we were to now look at this expression now, okay, we are going to substitute a boundary condition now. Okay, now we know over here BY is the reaction. Okay, that is BY zero. So BY is pushing up. Okay, so however, on the beam, or with reference to the beam, when X is equal to L, okay, V at L is equal to minus BY. Okay, it has to be minus because over here, this is the what? Over here, this is the reaction. Reaction is going up. Okay, so this is a static analysis. Something must be pushing up for the reaction to go up. Okay. So from here, we substitute this into the above equation. So you get minus BY is equal to minus omega naught L squared over L plus by 21 over 20 omega naught L minus by 3 BY. Okay. So over here, you have 2 BY will be equal to, this is 2, right? 1 over 2. So you have minus 1 over 2 plus by 21 over 20. You have 11 over 20 omega naught L. So therefore, BY will be equal to what? 11 over 40 omega naught L. Now, this is on the beam. On the beam is coming down. The reaction at point B will be equal to 11 over 40 omega naught L, and it's going upwards. Okay. Okay. Straightforward. Every steps over here you have seen before. Okay. I've explained it, everything. Okay. Nothing different or nothing unique. You did not learn anything new. Okay. The answer is what? The same. Simple. Okay. So that's why when I give you the solution, okay, use the way I teach you to solve the problem. Don't like, okay, I'm going to try figure out what is going on. Why do they use this? Okay, why is it this way? Why is it? You keep on asking why, right? And you try to figure out. Don't do that. Okay. Start moving. Apply what you know. Okay. And if you look at all this, okay, it is not that difficult at all. Are we clear? Okay. As I said, the last time when I was teaching this, or the last term, a lot of students have issue in the sense that it looks really complicated, and then in the end they keep on thinking with no action. Okay, don't do that. Okay, like when I reach over here, you look like, whoa, look at that, so many unknown. How are we going to solve it? Or when we come at this stage, right? Don't worry about that. Okay, keep on moving. Eventually, when you found the boundary condition, it's especially at this stage. Okay, at this stage, it's critical. Okay, now why this is minus again is because you're dealing with reference to the what? To the beam. You're not looking at the reaction. Okay, okay. I'm not going to bore you anymore. Understand it's a long weekend. I'm going to stop here. This week there's no new homework. Finish homework 1. Make sure you know how to do homework 1. Very important. Okay. If not, have a good long weekend, and I'll see you again on Thursday. Bye.